Today, we're going to be discussing our introduction to Google Cloud. In our previous lesson, we talked about Kubernetes. In this one, we're going to continue our discussion of the Google Cloud Console and talk about the other container-based or the other engines that are in the Google Cloud, which is the Google App Engine and the Compute Engine. So to quickly recap, so last time we talked about what is Google Cloud. We got into all the little APIs and services that they offer, the different pricing. We also talked about the different types of security that they support, like the PCI, the HIPAA, the ICDs, and all those for not just US, but worldwide security support. They also support multiple different languages, Java, Python, Go, PHP, and some others. We also talked about Cloud Launcher, which is similar to the launchers that are equivalent with like HostGator, Amazon, and some of the other third parties that are out there similar to Google Cloud. And then we really took the time, and the meat of the discussion was to walk through the whole Google Cloud platform, go through the free tier, and actually build out a Kubernetes container, deploy our containers to Kubernetes. And we took our old fallback Spring REST application that we've had kicking around for a while, and we wrapped that up in a container, and we deployed that from the command line to the Kubernetes interface as well. To continue our discussion, today we're going to cover what is an app engine. We're going to also look at what is a compute engine, discuss some of the differences between them and the Kubernetes engine. And then we're also going to build a simple Hello World app on the app engine. And we're also going to spin up a compute engine with Ubuntu running a Mongo database and a simple to-do app. I believe it's a Ruby app. So with that said, this is not going to be slides. I'm hopefully not going to talk your ear off with boring stuff. We're going to do more of a hands-on demo again today. So let me kick out of here. So first things first, we need to log into our Google Cloud Platform. We need to go to and create a project. Everything in the Google Cloud Platform requires some types of project. So this one's going to be just demo something today. So demo 234 has to be unique enough that it doesn't hit someone that's already out there. So create. And we look at our notifications. It's creating our project. So while that's creating, so what is an app engine? Well, an app engine is made up of a single application resource that consists of one or more services. So each service can be configured to use different runtimes and to operate with different performance settings. Within each service, you deploy versions of that service. Each version then runs within one or more instances, depending upon how much traffic you configured it to handle. So essentially, an app engine comes in two environments. We have what's called a standard and what is called flexible. So the app engine standard limits the runtimes by language, typically Python, Java, PHP, Go, and is very simple to get up and running, and also supports auto scaling, so you can scale it up and down as needed to test out your project. It also supports scale to zero. So if your application is getting absolutely no traffic, you're not being charged for it. So it's great for people just, trying out the services, playing around, or newbies, basically to get their feet wet with little or no cost to them. As for the App Engine Flexible, it allows you to deploy anything you can put in a container, auto scale, etc. So all right, now we have our project. So let's go pick our project. Okay, so now we have demo. And we have my project, which actually should go away. We'll leave it there for now. So for those of you who may have missed the previous presentation on this, if you sign up for Google Cloud, you get 1 year free, plus you get a $300 credit, which allows you to play with some of the additional features that Google Cloud gives you, which don't necessarily have any free tiers like the databases and like particular servers and that we're going to spin up. So if we go to our navigation menu, so last time we focused on this option here, the Kubernetes engines with the clusters, the workload, the services, applications, configurations, and storage, and so on. Today, we're going to start with App Engine. So let's go to our App Engine. So the first thing it says is, hey, welcome, build your first app. So let's create our first app. So the first thing we want to do is, like it says, select a language. So these are the different languages you can play around with within your App Engine. So bear in mind, App Engine really is designed for you to deploy an application to the Google Cloud Platform and let it handle and run your application. So this is not a container. This is actually deploying it to the Google Cloud Platform, and then you can kind of manage it within the App Engine interface. The big benefit of this is it allows you to build an application, throw it up here, play around with it, see if it works in the cloud. If it doesn't, you can go tweak it, fix it, get it to where you want it to be. And then if you want to actually deploy it or control it, you can put it into a container, or you can actually wrap it up and put it into the container engine. So for now, we're going to start with Java, since primarily I do Java development. So I'm always leaning on Java, though we could easily have done any of the other ones. So we're going to pick US Central, which is where we're at. Do next. And it's going to take it a minute to build this. And while that's building, we're going to briefly discuss some of the differences between the App Engine and Kubernetes. So when compared to Kubernetes, the App Engines, they're completely different things. So the App Engine Flexible is focused on application development. For instance, you have an application and you want to deploy and manage by Google, whereas Kubernetes is more about having your own infrastructure. Obviously, you can also deploy applications in Kubernetes, but as it's your own infrastructure, where you are the one directly managing how both the container and the applications will behave. So in a sense, Kubernetes is more flexible in what you can achieve. However, as a developer, you may not be interested in the infrastructure at all, only that your application works and scales. So for this kind of profile, App Engine Flexible is more suitable. Although if you want to manage a complete container infrastructure, then Kubernetes is the preferred way you want to go. Okay, so we now have our App Engine. So it says, let's get started. Let's close that guy out. So one of the nice things you see as you go through the Google Cloud Platform, if you hit something new for the first time, you almost always get some type of pop-up or tutorial walkthrough. So the first thing we want to do is, so we've got our project, we've created a new app, we've selected our language, we've selected our region. So now, once everything is done, we're going to use the Cloud Shell to clone and navigate to Hello World code sample. The sample code is cloned from a project registry to the Cloud Shell. So what we'll do is, so for those of you that weren't in the previous presentation, to get to the Cloud Shell, you can click this little icon here, activate the Cloud Shell. It opens up a small kind of containerized window within the browser. What's cool about this is it's tied directly to your project. And everything's here, all your SDKs, everything you need to use for Google Cloud is here. So I'm going to expand this. We're going to put this over here so you can watch what happens as we use it. There we go. And slide it over here. So the first thing it says is you should probably set your project ID. So if we set our project ID, so we come in here, our project ID is this guy, not the actual name of our project. And that's how you're going to refer or reference or deploy anything to your project. So the first thing we want to do is do Google Cloud config set project. So if you're kind of familiar with command line code generators like Selenium Roo or some of the other ones that are out there, they kind of give you little helpful hints as you go along the way to actually create your projects. All right, we're just going to type this out. All right, so now our project is qualified to this guy. All right, so now We now have our project set, so we now need to check out our code. Well, the first thing you can do is you can check, hey, technically I already have it because I ran this earlier, but this is just your local Linux configuration. So I'll clean up my interface here so you can kind of see what we have. So if you wanted to, you could read the README by doing a vim or a cat. If you do cat, if you're not familiar with Linux, that will just kick it out to your console here. And it just gives you some little walkthroughs of how to use it. All right, so first things first, we're going to check out a Git repository. So if you go to github.com, Google Cloud Platform /App Engine try Java, it's kind of their little hello world Java application. One of the things you will notice if you use the Cloud Shell a lot is it runs extremely fast. If you try to do this from the command line of your machine, it's probably going to take anywhere between 2 to 5 times as long, just depending upon your network traffic. If you do it through the Cloud Shell, you're using their servers, it's on the back end, and it streams. It's just extremely fast. All right, so we now have our App Engine try, so we'll go into there, CD, and inside here, so we want to configure our development. So you are now in the main directory for your sample code. You'll look at the files and configure your application. So where's our application? So it's a typical Java application. So if we look at the path, okay, we have our source. So CD, let's just do vim source main. Okay, we want Java, my apps. Okay, so we have demo servlet Java, and look in there. So here is our Java application that we're going to try to run. And as you can see, it's a servlet, and it's a straightforward do get text plain, and we're going to return a hello world. Very straightforward. Control X out of that. And then let's go look at the POM file. So the other thing, so pretty much straightforward servlet. The other thing we want to look at is we want to look at this POM because this is a Maven project. And the dependencies you need to run the App Engine Javas are, where is it? Okay, so we're using Java Maven compiler 1.7, App Engine version 1, target version is 1.964, and the Maven plugin is 1.3. The dependency you need is com.google.appengine. The artifact ID is appengine-api-1.0-SDK. And because we use the properties, you can use the tag $squiggle appengine.target version, so you can maintain all your version IDs at the top and not have to go hunt and peck for them. JSTL, JUnit. Here we are. So here's our dependency. Another one, com.google.appengine, appengine testing, scope test, and then com.google.appengine API stubs. And one other one you have to include for App Engine is in plugin. You need to use the com.google cloud tools for the Maven. So when it actually does the Maven build, it will use the App Engine tools. That's our POM file. So the hello app uses Maven, again, which means you must specify the project object model, or POM, which contains information about the project configuration and so forth. So let's test our app on Cloud Shell. Cloud Shell lets you test your app before deploying it. So just like debugging on your local machine. So make sure I'm in the root, which I am. So here we're going to do Maven, App Engine, run. Okay, it's kicking it off. It's running Jetty, and it's almost run. Now it's running. Now, the cool part is because you're just running this in a Linux window, essentially, if you actually want to kick off your browser like you were running in a local environment, you can click this little eyeball browser window for web preview, and it will preview your application on port 8080. So it's essentially already extended your console or opened it up to the world just for this browser window. So see HTTPS 8080 slash or dash dot dash its information to the console. And there's our hello world. So we know that works. So it works locally. So one of the tricks with this console is you have to double click twice, maybe 3 times sometimes, but you have to make sure that this little icon is solid, because if it's not, you're not working within this window. And if you're not working in that window, you have a tendency to actually kick yourself out or close your browser. So be very careful with that. All right, so we did the web preview, we killed it. Now, deploy. Uploading to the cloud. There's our dashboard. Check our services. There it is. Still running. Okay. If we want to view it in the browser, browse, and there's our URL. Give it a second to compile. And there's our hello world. So it was that easy. So you test locally by just doing app engine run. But if you actually want to deploy it, you do app engine deploy. And as you can see, it's now running over here. We have no version because we didn't deploy a particular versioning. We have 1 instance running. We really don't have a task queue at this time. Security scans, not set up. We have to actually enable the Cloud Web Scanner API, which we don't need at this time. You can enable firewall rules. So just like any firewall or DNS rules. The cool thing I like about this is you can actually type in some IP addresses and set specific rules. So one of the biggest issues I encounter a lot with setting up new WordPress sites is within the first few days of setting them up, someone always has a wild hair to try to do a denial of service attack and take my site down. 9 out of 10 times, it's always either someone's just farming the AWS servers to try and find an open IP address and they're just trying to hit it to see if they can hack into Amazon. But typically, all you have to do is just type in their IP address, and then you can put deny. You can also do a range. You can do all that from here. So you really don't have to go do it on the server anymore. You can do it straight from the console, which is kind of nice. Memory cache issues, so you can flush cache if you need to clear things out. So just some other nice little things you can do within the console. So I don't want to essentially waste my credit here. So what I'll do is we'll come in here and go down to instance, select our instance, and delete. And it'll take a second to take it out. And it's gone. So now if I go back over to dashboard, nothing's running. So that's the App Engine. So next, we're going to look at our compute engine. So let's go over here. We have compute engine. So like it says here, so the compute engine lets you use virtual machines that run on the Google's infrastructure. Essentially, you're creating micro VMs or larger instances running domain, Windows, or other standard images. It does have some features such as live migration and auto scaling within the managed instance group, but it's much more bare bones than the others. So remember, this is a VM, not a standalone container, so no shared resources across the VMs like you do with the container. So the VMs here, so the compute engine here is very similar to the Amazon AWS servers. So if you're setting up a VM instance here, the setup process is almost identical to what you do over in Amazon. So the first thing we want to do is you always have to pick a project because your billing and all that's tied to a project. So what we're going to do here for the compute engine, we're actually going to spin up two different Ubuntu servers. One we're going to install the Mongo database on, and the other one we're going to install a front-end application to run a to-do app. So the first thing we're going to do is, so we need to create an instance. So we'll create. Oh, still waiting. New project has to install the API. If for some reason you're missing APIs or you want to add additional APIs, we discussed this in the previous lesson, but you can come down here to APIs and services, and you can enable APIs. And the big ones that I found that you need for doing a lot of the engine work, so you need like the Google App Flex. If you want to do this via the command line or the console, it needs to install some API features. Kubernetes Engine API, this was required for our previous lesson. The App Engine admin allows you to manage your API through the command line SDKs. And the Compute Engine Interface Group Manager, and the Google Compute Engine Instance Group, which I think that's the one yes, that was the one it just installed. Great. So we have our Compute Engine. So now the API is installed, we can now create our first engine. So we do create. Name your instances unique. So this will be my backend instance. I will just use the default now, US East. So the machine types. So this is where it looks very similar to the Amazon AWS. So here you can create a micro instance, a small instance, 1 CPU, 2, 4, 8, etc. If you want to see how much it'll cost, you can always come out and look at the details or customize or upgrade your account. The actual pricing information, though, is all online. It's pretty straightforward. Let's go out here to cloud.google.com/compute pricing. And if you scroll down, the N1 tier is pretty much the same as the EC2 tier. Prices are pretty reasonable. You can do hourly, you can do monthly. So the standard one will cost you about $24 a month if you come down here. So if you do Iowa, oh, hey, look, this one at 1 CPU at 0.6, so that's the micro instance. It's only going to cost you about $3.88 a month. Not bad. Even if you jumped up to the one small, which has 1.7 gigs of memory, you're looking at $13. That's still not bad. If you go into the high memory ones, okay, it gets a little more pricey, $60. Hourly rate, maybe $11. So like if it's around Christmas time and you need some extra bandwidth for a couple of days, you could always spin up to the high mem, and then when you're done, you just spin it back down. Because pretty much it's what you deploy to your VMs or what you deploy to your containers. You can spin them up, you can spin them down, you can scale multiple, just whatever you need. I find this a little bit easier to do here with the Google than I do with Amazon. However, Amazon keeps adding more and more new tools, so Amazon is pretty much in line with what Google's doing. It's just a matter of the different tool sets. All right, so for this demo, so we're building the backend server. So this is going to house our MongoDB, our Mongo database. If we want to actually deploy a container image, we can by checking this guy, and then we can pick our image. Just be careful with this, because if you deploy containers to this, it's essentially being deployed to a VM. So it's being deployed to an actual machine. Whereas deploying it to Kubernetes, the container can be spun up in multiple machines with the load balancer. Here, you're actually deploying it to a VM. So yes, you can scale, but it's within the VM, not necessarily within the container. Our boot disk, they have multiple variations. So we have Debian, we have CentOS, Ubuntu, there's Red Hat, SUSE. We even have Windows servers. So if you need to play around with some Windows or SQL Server, here you go. You got some Windows servers you can use. The one today we're going to play around with is just Ubuntu 14.4, standard persistent disk, 10 gigabytes. Select. We're going to allow default access. You can actually change the service account, or you can configure specific service accounts for your API access. For now, we'll just use the default. The other thing we need to do is we need to set our firewall so that we can allow HTTP traffic. This is very similar to what we did with launching an internet business with the Amazon AWS. You needed to set up the ports 8080, basically whatever ports you need that you want to actually connect to your server. So click Create. And while this guy takes a minute to start, we will go ahead and create a second instance. And this one's going to be for our front end application that we'll deploy. We're going to keep it as US East. We're going to still do a micro instance. I'm going to use the same Ubuntu image, same persistent disk size, allow default access, allow HTTP traffic, and create. And watch our notifications while these wrap up. Should take about a minute tops. All right, so we got our backend instance and our front end instance. So if we want to actually just connect to these, you can SSH into them by clicking the SSH here, and it's going to create a Cloud Shell connection. The first time you connect, when you try to do anything, it's going to prompt you to create your SSH keys. I had a couple issues with this. It will say it's doing it, but it will fail, and I apologize for that. But it just seems to be a little bit of a bug with the console right now. So you can do the SSH from your local terminal, but after the last presentation, you're going to find that using the cloud terminal is the fastest way to do this. So we're going to want to do a gcloud, which is the cloud SDK. We want to compute a project, and this is actually going to be our project ID. So that was from my previous project that I just deleted. All right, so we got gcloud, compute, our project ID. We want to SSH into our zone, and we're going to leave those blank. Oops, hey, you don't have an SSH key. Well, we'll just quickly create one, and it doesn't like it because it's blank. That's fine. Right now, we are now SSH'd onto our box. So if we actually did cd So right now you have access only to your instance, only to your home directory. But we still need to do some basic house cleaning of our instance. So the first thing we need to do is make sure we get the latest Linux updates for Ubuntu. So to do that, you do the sudo apt-get update, which pretty much anytime you install a brand new Linux server, you should almost always do a apt-get update. If you're on CentOS, I think it's something else, maybe yum update. Next, we want to install MongoDB. So by default, when MongoDB installs, it's going to also start the service. We need to stop it, and then we need to create a directory for our MongoDB, a specific home directory for our MongoDB for ourselves, and then run the MongoDB server again in the background on port 80. So we do psef rep mongo. It's currently running on SPID 6018. So if I did service MongoDB status, it's currently running. And again, there's our process ID. So we want to stop it. So you need to do sudo service MongoDB stop. Now it's in the stop waiting. So next we want to create a DB folder in our home path. So sudo make directory mkdir home DB. We now have a DB folder. And now we want to restart the MongoDB pointing to our home DB path. So sudo MongoDB set our DB path to home DB, run it on port 80. We're going to fork it from the original. We're going to set the long path to be var temp MongoDB. And now if I do a status, it says stop waiting. But yet if we do a top, there it is. It's running on the very top. So if I do tsef Mongo again, so there it is, it's running and it's on 6070. All right, so that's it for the MongoDB. Mongo's running, so we kill that SSH session, and we go over to the front end and we open up that SSH. We'll have to do the exact same thing again with the keys because it's a different server. But again, the first thing we'll have to do is we'll have to do the gcloud compute to our project so that we tie the Linux connection to the console so that each can communicate with each other. And when in doubt, if you forget what you're doing, just kind of read some of the documentation as it comes up. So don't disregard it the first few times you use it. After you get used to these interfaces, by all means, you can probably ignore it. But just at the beginning, kind of read through what's popping up on the screen. So again, we have to install the updates. Since this is going to be our front end, we need to install Node.js. And we also need to install Git. So this first one's installing the source for Git. And as you can see down here, it says, hey, okay, you've installed that, but now you also need to install Node.js, which we'll do. Okay, so now we have Git, we have Node.js. Now we need to install our sample application. So we go git clone, we're going to GitHub again, we're going to go to Google Cloud Platform again, and this time we're going to get our to-do MVC app, MongoDB example. All right, so we've now installed, or we've now downloaded the source code. So it's now in the to-do MVC Mongo. So we'll run a kind of a combined command. So we're going to cd into our to-do MVC folder, and then we're going to install the application. And we're going to set the application for 8080 to port 80 for server.js. And then we're going to start our web application. To start it, so if we leave off NoHub, if you were to run this and then close this window, you just killed the application. So what NoHub does is it allows you to run the application as a service behind the scenes so that when you exit out of your session, your application is still running. So we'll kick that guy off. We're going to exit out because now we should be good to go there. Well, apparently I have a typo. So what it should be doing is it should be pulling up a little MVC application that just allows you to add a bunch of basically little to-do commands to a list, and then you can delete and add them. Unfortunately, for some reason, it's not wanting to kick off. So to wrap up, so we continued our discussion on the Google Cloud interface today. We talked about the app engine, the compute engine, and the differences between all three different types of engine type. Whereas the app engine is more for developers developing and testing a single application. Your compute engine is more designed to spin up actual VMs, unlike the Kubernetes cloud where you can spin up multiple containers and scale and all that with Kubernetes. And then we walked through a demo of the app engine actually deploying a simple Hello World app. And we tried to walk through building the compute engine, pushing out a MongoDB database on one particular VM instance and actually spinning up a MVC to-do list on another. Unfortunately, that did not work in today's presentation. Thanks again for joining us today. We appreciate your time and would love to discuss any future topics. You can send us questions, comments, or suggestions through any of these methods, info@developernerd.com, https://developernerd.com/contact us. We're on Twitter @developernerd, or we're on Facebook, facebook.com/developernerd. Our goal is making every developer better. And it starts with you. Have a great night.